everybody. Today we're looking at section 4.10, which is writing quadratic functions. What we're going to look at today is two different methods on writing equations once we've been given some data. The hardest part about this is trying to figure out what data did they give us. Well, we know we've got two forms to the equation that we're used to looking at. The one we're not going to use today is standard form. So the two that we are going to use will be, the first one, vertex form, x minus h squared plus k. So the data that we're going to be given will be the vertex, and they're going to give us a random point. We're going to use that information into vertex form. We'll be plugging the vertex in where h and k go, and the one random point they're going to give us will be in the form of an ordered pair, x, y. So there will be numbers in right here. We're going to take those two numbers and plug them in where x and y will go. And the only thing that we have left that we haven't plugged in, if you notice, is right here, a. That's what we need to solve for. We need to solve for a. As soon as we get an answer for a, then we're done. And we can just simply write the model with whatever that a number is. The second form we're going to look at is if they give us two x-intercepts and one random point. If they give us two x-intercepts, which are, remember, the places where the curve crosses the axis, then we're going to use those 2 points plus the one random point. We're going to use our intercept form. So if they give us an intercept, they're going to be telling you a p number and a q number. That random point, remember, is xy. We will plug in that x number twice, plus the y term. And again, you notice we only have one thing that we don't have. So that's what we need to solve for. Solve for a. And then we can go ahead and write the model. We'll be finished. All right, so the first one we're going to try is vertex form. So I would suggest right away that you write that form on your paper so you can look at it and you know exactly where everything's going to go. Vertex form, a parenthesis x minus h squared plus k. Our vertex is negative 2, 4, so I need to put this in. Remember, vertex, your x-coordinate always goes in as the opposite sign of what you have. A is the one that we don't know, so our vertex is going to be negative 2 opposite, so it's going to be a plus 2, quantity squared. Your k value is plus 4, so you're done with that, done with that. The random point, x, y, negative 4 is x, so your negative 4 is going to go right here where x would go. The y term is negative 1. Negative 1 goes on the other side. And we have filled in everything except for a, and now we just have to crunch this together. Negative 1 equals a. Negative 4 plus 2 is negative 2 squared plus 4. Negative 1 equals negative 2 squared is 4, so it's 4a plus 4. Move the 4 to the other side. Negative 5 equals 4a, and a equals negative 5/4. Now you just need to take your answer and write the model. Y equals negative 5/4. Your vertex, negative 2, 4, so it goes in as x plus 2 squared plus 4. And you're done. Your second one, your vertex is 4, negative 5. Your random point is 2, negative 1. And again, we're going to write the model. Y equals, inside the parentheses is the vertex, x minus 4. Do the opposite of 4, so negative 4 squared. Your k value is negative 5. We know this is a out here. Now we can plug in our random point of 2, negative 1. Your x value is 2. 2 minus 4 squared, subtract 5. Your y value is negative 1. Negative 1 equals a. 2 minus 4 is negative 2 squared, subtract 5. Negative 1 equals 4a minus 5. Add 5 to both sides. 4 equals 4a. A is 1. And you can write your model. Y equals, a is 1. We don't even need to put the 1. I'll just write it there for the sake of you knew what that number was. Your vertex is x minus 4 squared minus 5. And there's your model. Very straightforward, very simple. Your second form was the intercept form, so again, I would suggest you write that model for intercept form on the top. A, x minus p, x minus q. Our random point in this one is negative 3, comma 4.5. Y equals A. Let's put the intercepts in first. X, and then your opposite of negative 4 would be plus 4. And your second one is x minus 0. So we just put x. Now we can put in our random point. Your x value is negative 3 each time. Negative 3 plus 4, and also a negative 3. Your y value is 4.5. 4.5 equals A times negative 3 plus 4 is 1 times negative 3. 4.5 equals negative 3A, and then you solve for A. 4.5 over negative 3, and you'll need to get that answer. Negative 1.5, and you have everything you need to write your model. Y equals your A value that you just got, negative 1.5. Your intercepts, first one was at negative 4, goes in as x plus 4, and the second one, x minus 0, is just x. So we have 1.5 times x plus 4 times x. And we're going to try this just one more time. Your intercepts are negative 2, 0, and 5, 0. Y equals A, x, opposite sign, x plus 2, x minus 5. Random point is at 6, 2. 6 plus 2, 6 minus 5. Your y value is 2, so I put 2 on the left-hand side. 2 equals A. 6 plus 2 is 8. 6 minus 5 is 1. 2 equals 8A. Be careful here. This is an easy place for people to make a quick mistake. They see the 2 and the 8 and they think that A is 4. We're dividing by 8, so it's actually 2 over 8, 1/4. Our model, y equals 1/4, parenthesis, x plus 2, x minus 5. There you go. That's it for writing equations given information, whether it's in intercept form or it's in vertex form.